In this video, we are going to talk about how we could create sine and cosine functions that will create the same graph. So they are equivalent functions, but one is a sine function and the other is a cosine function. A lot of these key characteristics that we are going to use when we are creating our equations, our functions, is going to be the same. And so we are first going to start off by filling out this chart with these key characteristics because they're going to be the same for both of our functions. First off, to find our amplitude, we need to figure out our midline because our amplitude is the distance between the maximum point and our midline. If we look at this function, our minimum value is going to be -2, and our maximum value is going to be 0. So to figure out our midline, we are going to add those two values together and divide them by 2, which is going to give us a midline of -1. So that a midline is going to be y equals -1. It could be represented by this dotted line right here. This is the horizontal line that splits our curve in half. And so from there, we can figure out our amplitude because the amplitude is going to be the distance from the maximum point to our midline or from the minimum point to our midline. This is our amplitude, which in this case is going to be 1. That is the distance from the midline to either the maximum or the minimum point. Next, we are looking at the period, which is the length of one full cycle of our function here. So this line in yellow from one maximum to the next maximum is going to be the period. And so we can figure out the length of this line by taking our second point, 5 pi over 6, and subtracting our first point, which is pi over 6. That is going to give us a period of 4 pi over 6, could simplify as 2 pi over 3. So that is our period, 2 pi over 3. That is the length of one full cycle here of this function, from one maximum to the next maximum. Now our next row asks us whether or not there is a horizontal reflection. So was this function reflected or flipped over our x-axis? Because after our y-intercept, our function is increasing, we are going to say that no, there is not a horizontal reflection here. So this means that our lead coefficient, our a value, is going to be positive. Finally, this table is asking us to figure out the frequency or the number of cycles there are within 2 pi. And so to find our frequency or our b value, we are going to take 2 pi and we are going to divide 2 pi by the period. So we're going to take 2 pi divided by 2 pi over 3. We are dividing by a fraction, so another way we could write this is 2 pi times the reciprocal, 3 over 2 pi. And when we do that, the 2 pi's will cancel out, leaving us with our frequency or our b value of 3. This tells us that 3 is the number of cycles of this function that will occur in 2 pi. We have now found all of the common information that is going to occur in both of our functions here. So I'm going to go ahead and erase this information on the side. And let's take a second to look at the parent functions for sine and cosine. Start out by using this information to create a sine function. So we know that if we are looking at the parent function of a sine function, the y-intercept is going to occur at the midline, which for our parent function is at the origin. So the only difference between this function and the parent function as far as horizontal and vertical translations go is this function has just been moved down 1 unit. There is no horizontal translation here. This function has not been moved to the right or to the left. So we are going to leave our h value as 0. And so this is our parent function here that we are working with. We have y equals a sine of b times x minus h plus k. So we are going to use this information that we have created, we have put in our table, to substitute these values into our formula. That is going to give us y equals a, our amplitude, which here is 1. We also know that this lead coefficient is going to be positive because we do not have a horizontal reflection. So we are going to have y equals 1 times the sine of b. Our b value is 3. And we just said that we are not going to have a horizontal translation. This function has not been moved right or left. So h is going to be 0. So that is just going to leave us with 3x in parentheses. And then finally, our k value is our midline, which is -1. So this is going to be the sine function that represents this graph here. Now let's do the same thing with cosine. I have pasted in here graphs of y equals sine of x and y equals cosine of x. These are our parent functions of these two functions here. And so you'll see that the only difference between sine of x, which is in pink, and cosine of x is that sine of x has just been moved to the right. So the only difference here is that horizontal translation. To get from cosine of x to sine of x, this function has been moved to the right. So when we are creating our sine of x function, everything is going to stay the same. The only addition we are going to have is a horizontal translation. A horizontal translation. So I'm going to add this below our table here, and we are going to figure out what is that horizontal translation. When we are looking at our parent function here, the y-intercept of a cosine function occurs at the maximum point. If we are looking at our function here, to get from our parent function, which has a maximum point as a y-intercept, we have to move to the right pi over 6 units. So if we took this blue function and we shifted it to the left pi over 6, then we would have a maximum point at our origin, just like our parent cosine function. But this function here does not have that maximum point at the y-intercept. It has instead been shifted pi over 6 units to the right. So we are going to identify our horizontal translation as pi over 6. And so given all of this information here, that is the only addition to our cosine function. Put all of this information together and write our function. So transformation form looks the same as sine, except instead of sine, of course, we have cosine. And we are just going to substitute this information into this function. So we are going to have the same a value of 1. Our b value is still going to be 3. But this time we do have a horizontal translation of pi over 6. And then finally, our k value, our midline, is the same, which is -1. If you graph both of these functions in your calculator, it's going to have the same graph. So these are equivalent functions, even though one is a sine function and one is a cosine function.